Good morning, my dear students. For today's lesson, we will discuss about the ionic compounds, how they are formed, and I'm going to show you the different elements and their location to the periodic table, which are responsible for the formation of ionic compound. And I'm going to give their different properties. What are ionic compounds? Ionic compounds are formed between a metal and a non-metal. The chemical combination between the two types of elements results in the formation of ionic bonds between atoms. Ionic bonds are the electrostatic force of attraction that holds cations, positively charged atom, and anions, negatively charged atoms together. Sodium chloride NaCl or table salt is an example of an ionic compound. Why? Because it is the combination of sodium, a metal, and chlorine, a non-metal. Sodium becomes a cation as it loses an electron and transfers to the chlorine atom. Chlorine, gaining the electrons, becomes an ion, and eventually an ionic bond is formed holding these ions together. In your module, third week, page 4, you have your table 1, which shows common ionic compound and their uses. Read your table and take note of the importance and uses of the different ionic compound. Next is the location of the element which are responsible for the formation of ionic compound. I am going to show you a video that shows their location in the periodic table and their properties. After the video, you are going to have your performance stats about the location of metals, non-metals, and metalloids in the periodic table.
Non-metals and metalloids, and sometimes metalloids are called semi-metals. They mean the same thing. And you can identify metals, non-metals, metalloids by your periodic table. Okay, so your periodic table tells you a lot of information, as we already know, but it tells you even more. Okay, so we can break up the periodic table in a very easy way, and it will tell us what elements are metals, which ones are non-metals. On most periodic tables, like this lovely one in your book, you will see this very bold stair step down. Okay, and it's there for you. Okay, this stair step tells you where the break is between metals and non-metals. I specifically picked one that doesn't have it bolded, that way we can draw it together. All right, so you're going to start at the corner right here and go down, and then the first stair is between boron and aluminum. Okay, and then you just draw a staircase. Easy. Boom, you're done. Okay, and then anything on the left side of your stair step is going to be a metal. Anything on the right side of your stair step is going to be a non-metal. Okay, and remember that these guys down here, your inner transition metals, even though like technically these are kind of to the right of that stair step, remember that these fit into here. So all of this stuff, this is all metal. Okay, there we go. All right, then we have our non-metals over here. Right, this lovely area. Hydrogen is the weirdo, okay? The first period has some weird stuff going on with hydrogen and helium, but hydrogen is a non-metal. He technically is in the non-metal category, but he's way over here, all right? So he's the only kind of outlier. And then along the stair step, we have some semi-metals or metalloids. All right, there's my best picture of a periodic table for you, and we'll do the same thing, okay? So you would start up at this corner right here to draw your stair step, down, over, down, over. We'll just relabel it. Anything on this side is a metal. Anything on this side is going to be a non-metal, all right? And then along the stair step, anything touching the stair step is going to be a semi-metal, except for aluminum, okay? We know that aluminum is a metal, right? You have your aluminum cans, you have aluminum foil, okay? Aluminum is a metal, so he does not count as a semi-metal. Other than that, the things that are touching your stair step are going to be metalloids or semi-metals. So boron, silicon, germanium, arsenic, which is As, arsenic, Ar is argon, okay, so be careful of that. Sb is antimony, tellurium, polonium, okay? So here are your semi-metals. Good, let's pick the right color. Okay, here are your metalloids. Okay, but everything else, these are metal as well, right? And your own little outlier right here, hydrogen. It's technically on the non-metal side. Okay, so you should be able to look at your periodic table and determine right away, you know, is something a metal, a metalloid, or a non-metal, just by looking at where it is on your periodic table. Okay, and now let's go over properties of these things. So we have metals here and non-metals here, and we're just going to compare them. Here, we'll go one at a time. So properties of metals. All right, first of all, they form cations. I know we haven't talked about ions yet. We're going to talk about that more in chapter 4 with ionic bonding, but they're going to make cations, and the T in cat will kind of help you remember that it's a positively charged ion. So metals will form cations, which are positively charged ions. They give away electrons. I promise we'll learn more about this later, but either way, just know that that's a property of a metal, okay? So they form cations, and they are typically solids at room temperature. Almost all of them. There's only one kind of exception to the rule. You know what it is? It's mercury, okay? Mercury is a liquid at room temperature, but almost all of the other ones are, well, not almost all of the other ones are solid at room temp, okay? Makes sense, they're metal. All right, they have high luster, which means they're shiny, okay? Which is, of course, something that we know about metals, one of the reasons that we use them for jewelry, okay? Okay, they can conduct electricity and conduct heat. So conducting electricity, you flip on the switch to turn on the lights, what happens is electricity is going to flow through copper wire, typically copper, right? Copper is a metal. Electricity is going to flow through metal. It's not going to flow through air. And conducting heat, that means that it's able to have heat pass through it very easily. Okay, so good example of this would be like cooking, okay? So when you're going to boil water on the stove, you pull out your metal pot, okay? You don't pull out a wooden pot. For very obvious reasons, okay? But that metal pot is able to conduct heat very well. So it's taking the heat from the stove and it's conducting that heat into the water in the pot to heat it up, right? So that metal can conduct heat. Malleable, all right? I promise this is something that will be tested. This lovely word, malleable, it just means that it can be bent or it can be rolled, okay? And that's obvious for metal. Think about a paperclip, right? You can bend that paperclip very, very easily. That paperclip is metal, right? It's malleable. Right? A ring, jewelry in general, is made of metal. Why? Because jewelry is malleable. Metal is malleable. You can make, you know, any kind of crazy different shape that you want out of metal because it is malleable. It's able to be bent, okay? Ductile is kind of a similar idea as malleable. It just means instead of bending it, you're able to draw it into a wire. Metal has a high density, so those solid metal particles are much more compacted. than nonmetals. Metals have high melting and high boiling points, which is kind of why metals are solid at room temperature, right? Metals are actually the majority of the elements on our periodic table. Okay, so if I look at this beautiful situation, all these guys here are metals. There are a lot of metals in comparison to this tiny amount of nonmetals. Okay, so majority of elements are in fact metals. And last but not least, metals are typically involved in just ionic bonds. There are some covalent bonds when they're in like polyatomic ions. But typically, if you see a metal, you can easily assume it's going to be an ionic bond, typically, right? On to the nonmetals. Okay, nonmetals are basically the exact opposite of your metals. So metals make cations, they make positively charged things. Nonmetals are going to make the opposite. They're going to make anions, which is a negatively charged ion. Again, we'll talk more about this in chapter 4, but just know right off the bat, metals are going to make positive things, nonmetals make negative things. Okay. Nonmetals can be solids, liquids, or gases at room temperature. Only bromine is a liquid at room temp. But we do have a lot of gases, so all of these guys, these are noble gases, right? So these are all gases at room temp. Almost all the halogens are gases at room temp. Bromine's the one exception. Oxygen's a gas, nitrogen's a gas. Then you have carbon is solid at room temperature. You either have carbon as a diamond, right? Or you have carbon as graphite in your, like what you would use as your pencil, carbon graphite, right? Your pencil lead. You get the idea. You can have solids, liquids, or gases at room temp, okay, for nonmetals. And they're basically the exact opposite, again, of metals. Metals have luster. Nonmetals are lackluster, which just means they're dull, okay? Again, think about the graphite in your pencil. That's not, like, shiny, right? Your pencil lead is not shiny. It's very dull. Nonmetals are good insulators, so insulating electricity or insulating heat. All right, they are not going to conduct electricity. They're going to insulate it. They're not going to conduct heat. It's going to insulate it, which... if you think about like a house, right? You have insulation in your house, so the space between your wall and the outside, they usually fill that with insulation, is what it's called, right? They're not going to fill that with metal. They typically fill that with some kind of foam, some kind of non-metal, because what that does is it doesn't easily let heat pass back and forth between the outside of your house and the inside of your house. So if you have like nice air-conditioned rooms inside your house, that's not going to, be conducted through the insulation. You're going to keep your house nice and cool in the summer. If you're turning on your heat in the winter, that heat is not going to be conducted through the insulation. Okay, it's going to stay nice and warm inside your house in the winter. So nonmetals are very good insulators. All right. Instead of being malleable or ductile, nonmetals are brittle. Okay, and again, if you think about your pencil lead, we all know this to be very true, right? You click your pencil lead and you go to press down on your mechanical pencil and crack, it breaks, right? Because it's brittle. And then you click for your next pencil lead and you go to draw again and then crack, it breaks again. Non-metals are very brittle, okay? They have a low density, especially things that are gases, right? They are spread out as much as possible. They're not compacted, they are spread out. So very low density substances here. They have low melting point, low boiling point. Last but not least, nonmetals are going to be involved in covalent bonds and ionic bonds. Okay, so even though there's not very many of these nonmetals that are involved in bonding, right? Because typically my noble gases are not involved in bonding, so I really only have this amount right here of nonmetals that are going to be involved in a lot of chemical reactions. They're involved in ionic and covalent bonding. Okay, nonmetals bond a lot. Okay, the only other thing to talk about would be metalloid properties, right? They basically just have properties that are both metal and non-metal. Okay, so they're kind of a mixture between the two. They're metalloid. They're not really one, they're not really the other. They can fall into both categories. Okay, so a metalloid would like have luster but be brittle, or it would be less conductive than your average metal, but it would still be able to conduct some electricity or some heat. So it's not quite a non-metal because it can conduct electricity or it can conduct heat, but it's not quite a metal because it's really less conductive than what they're able to do. So they're basically just kind of the guy stuck in the middle, okay? They have like a property of one and a property of the other, all right? They're wishy-washy. All right, that's it. Make sure you're able to look at your periodic table to determine metals, metalloids, and nonmetals, and know their properties. Good luck.
So, as I've said a while ago, for performance tasks, show the location of the metals, nonmetals, and metalloids in the periodic table. Use one long bond paper and your coloring materials. If you're done, have it picture and submit via messenger for checking. That's all for today's lesson. I'm going to give you your short quiz as an evaluation on after the next topic. That's all, and God bless everyone. Thank you for listening.